say problem 2 in the first homework. So this is A and B, and it asks you to first construct the truth table and then draw the logic circuit. So first, I'm just going to draw my truth table. So what I always start with is just writing out all the possible combinations of 0 and 1 for A and B. So that's going to be if they're both 0, if A is 0, B is 1, if A is 1, B is 0, if A is 1, B is 0, B is 1, sorry. So that should always be your first step, is just all the possible combinations of A and B, and then you go from each of those combinations to find out what C is going to be. So since in this case, C is equal to A and B, so 0 and 0 is going to be 0, because the only case that A and B is going to be true is if both are 1. Oh, wait, guys, please don't annotate. That's going to make this really confusing. I don't know how to erase that. Okay, I'm just going to keep going. So 0 and 0 is 0, 0 and 1 is 0, 1 and 0, 0, and then finally 1 and 1 is going to be 1. Because and you need both of them to be true in order for it to be true.
When you say 1 and 1, you're multiplying, or you like?
It's neither. It's not like a mathematical thing. It's just like if you imagine, I don't know, if you imagine like energy or something coming in from both A and B. It's like with an or, it's if you have something from one or something for the other, then it's true. But for and, you need something from both in order for C to be true.
Got it.
So that's or. That's just like what that means. And is you need both of them. So that's that truth table, and then you just draw it like it shows up here. A, B, you do your AND gate, there. And these like symbols, that's just the symbols for those gates. I don't know if there's a huge amount of logic to why the different diagrams are for the different gates, but that's how you would draw that. I hope that helps.
Yeah, I had it correct, actually.
Oh, great, good for you.
Awesome.
Perfect.
Thank you so much.
And then just quickly, for the more complicated ones, like for E, for example, generally what I try to do to make it easier for myself is just go really step by step. So like I'm not going to go through all the values, but say we're doing E. So I would do my A column, I would do my B column, then I would do my A or B column. Then I would do my C column. And then I would do finally the answer, which is A or B or C. So then if you do it like this, you're never thinking about more than 2 columns each time. And so like this is going to take a few more steps than the one I just did and be a little bit more complicated, but it's the same thing. It's still like, in order to come up with the A or B column, you look at the A and B. In order to come up with the C, it's just normal. In order to come up with the A or B or C, you just look at the A or B and the C. So it should always be just like looking at 2 columns to come up with the next column. If you try to do more in your head, then it gets a little confusing. Okay. Is there another question that I should answer, Rachel, from the chat?
Nothing else about this assignment.
Okay. Okay, so we want to move to homework 2.
Let's pause for 1 second. Does anyone have questions on homework 1?
Yes, I do. My name is Rocco, and I have a sideline question. What is the right pronunciation? XOR or XOR?
I say XOR, or you can just say exclusive OR. I don't think it matters too much as long as people know what you're talking about.
All right. I got used on XOR, so but I'm not sure is it right or not.
That's fine.
All right, thanks.
Of course.
For the traffic problem in homework 1, I had to use trial and error, but is there a formula or like a procedure to find the right way the fastest?
So that's an optional problem, so we're not going over those in this session. But I can just say that there are multiple different ways that you can solve this problem, that you can draw a circuit to implement this logic. But yeah, I think basically just trial and error is sort of it for this problem.
Ava, how would you like start to think through the basics? Would you draw it out, or like, are there any key?
For this, the way, yeah, I guess drawing it out, if that helps you. The way that I did it actually is like looking, okay, so the light should only be green for the minor street if there's traffic on the minor street but no traffic on the major street. So like if you look at that, that means that like the minor street has to be, or no, the major street has to be a 0 and the minor street has to be a 1. And that's the only case in which you can get a 1 for the green light. So it's sort of like working backwards, I guess, like what has to be true, and then like building your truth table sort of backwards. I don't know if that helps, but that is how I did it.
Perfect. Let's go to 2, and then we can actually end on homework 1 if there are still remaining questions, because I think that's where the bulk of questions lie. So Ava, if you want to switch over to 2, there are some questions about the summation problems in homework 2, and then also solving for the decimal on questions 1, 3, 4.
Okay. My screen mirror. We're back. Okay. So we're doing. So the summation, was that the one that people wanted?
Let's just go through like kind of one for each section, and if people have follow-up questions,
of course,
take them.
Okay, so let's start with the first problem, which is just giving the values of these trig functions. So let's do, why don't we just do 3? So they give you the unit circle here very conveniently. So if you just look, sine of pi over 3, you just find that angle. Pi over 3 is right here. This angle right there is pi over 3. And let's just draw the triangle so it's super clear. So sine is, so this is a unit circle, so you know that the radius is always 1. And sine is going to be the opposite side from the angle over the hypotenuse. So hypotenuse is 1, so you don't have to worry about that. So it's just going to be the opposite side from the angle here. So that is the y-coordinate of this point, which they give you right here. So the answer to sine of pi over 3 is just root 3 over 2.
I don't mean to interrupt. The Canvas asked for it in a decimal format, and I was unsure how to do that.
Well, this wouldn't be a decimal. Really? What? That seems strange because this is not an angle. It's not asking for an angle.
I got the same thing, but I wasn't sure how to put it in a decimal form like the Canvas wanted.
I guess just like putting your calculator root 3 over 2 and round to like 2 decimal places.
Okay, thank you.
I mean, I hope that's right.
Okay.
Hello.
Let me ask a question.
Hey guys, please ask your questions in the chat, and I'll watch for them so Ava can keep going.
Okay, so I guess we can come back to this if there are more questions about that, but basically all of these are the same. I guess the slightly more interesting or more confusing ones are the tangents, but same process. Tangent is just opposite side over adjacent side. Same process for all of these. So that is problem 1. Problem 2 is about converting between Cartesian and polar coordinates. So I guess we can do one of each of these. So let's do the first one. So generally how I would do these is draw it out so you have sense of what it looks like. So here we're going from Cartesian to polar. So let's just draw our little Cartesian coordinate system. So it's x equals 3, y equals 4. So 1, 2, 3, 1, 2, 3, 4. So that is going to be our point. So if we're trying to get polar coordinates out of it, the two things we need to know are theta, the angle, and r, the distance from the origin. So 3, 4. So how you can do this is a right triangle, so you can use a squared plus b squared equals c squared. So 4 squared plus, sorry, this is a, b, and c, just Pythagorean theorem. So 3 squared plus 4 squared equals 5 squared. So I just did that in my head, but it's a 3, 4, 5 triangle. You see them a lot, so you just end up knowing that those are what the points are. So r is 5, and then in order to find that angle, this actually says you can use a calculator. So basically, you can do this in a few ways, but you can use any of the trig functions. But for example, you could say, let's do it with the x. So x equals r cos theta. You could also do it with y equals r sine theta. But you just plug in your x is 3, your r is 5 cos theta. Just put that on the other side. You have arc cos of 3/5 equals theta. And I don't know that off the top of my head, but it is, I mean, I guess I could find out, but you just plug that into your calculator and it will tell you. Some of these are going to be like nicer, but that is the same process for all of them. Okay, let's do
There's
one.
a question about if x equals 0, how to calculate theta. So I think that corresponds to number 4.
Yeah, we can definitely do that. So I would do similar, draw it out, because specifically with this, it's easier to do it if you can visualize it. So your x is 0, so you don't need to go any in that direction. So it's just like this. Okay, so in this case, your theta will be this angle and your r is this. That might not be super obvious because it's sort of hard to see how you would draw your triangle in this case, but you always know that when you're converting from Cartesian to polar, your angle is going from the positive x-axis. So like in this case, it's going from the x-axis to the y-axis. So this one you can sort of do without any calculation. You can just see that theta is pi over 2 and r is 1. Okay. So now I guess I will go, I'm just going to erase this, or I can do it after. I'm going to go the opposite direction, just do one of these. So this is actually interesting. It's sort of the opposite. If we look at the first one, it's sort of the opposite of the one we just did. So let's draw this out as well. So r is 1. So the distance from the origin is 1, and theta is 0. So the fact that theta is 0 means that you didn't move any from the positive x-axis. So it's just like this. And this is 1. So once you've drawn it out, all you do is look at put your x and y and look at where that point is. So so this point is at 1, 0. So x is 1, y is 0. So yeah, for all of these, you just remember your two formulas, which are x equals r cos theta, y equals r sine theta. And those will get you everywhere with these. And drawing it out. I think that is always really, really helpful. See what it looks like, and you can always put like polar coordinates on your Cartesian graph or the opposite way around. Okay. Problem 3, exponents and factoring. Okay, so I guess I'll do one of these first ones. There's only two. So basically the exponent rules, this is like reminding your exponent rules. So let's do this first one. So small. Okay, so this is going to be, so when you have like the same variable to a power multiplied, you know that you can add them. So this is going to be like the first round of simplification would be x to the 7th over x to the 3rd, because 5 plus 2 is 7. And then when you're dividing the same variable to powers, you subtract. So 7 minus 3 is 4. So it works the same for the other problem as well. Okay.
Go over number VI under B.
BI, the first one?
VI, BVI. It's e to the
Oh,
third,
this one.
the second.
BI, okay. Sure. So I guess this is the most complicated of these ones, but how I would do this is, first thing I would look at is the numerator, so the top of the fraction. And I would look at what those two polynomials have in common. So like, what's the biggest thing that I can take out? So that would be, so you look at the e's first. So the biggest power of e that you can take out of both of those polynomials is e squared. And then you look at the x, the biggest factor of x you can take out is just x. And then you factor that out. So you're left with, in the first polynomial is just ex, and the second polynomial is just 1. So you're left with that over ex plus 1. And then you can see that ex plus 1 and ex plus 1 cancel. So you're left with e squared x. Does that make sense?
Yeah, that's perfect. Thank you.
Okay. So it's a similar process for the other ones. Like this right here, you can see is a difference of squares. But yeah, factoring. Okay, let's move on to 4. Okay, so problem 4 is summations. So A is evaluating the following summations. So I guess we can do one of these. Let's just do the first one. So it's the same process for all of them. So basically what this notation means is that the variable k is starting from 1, the number you see on the bottom, and it's ending at 9, the number you see at the top, and you're just adding. So this would be 1 plus 2 plus 3.
Could you zoom out this screen, please?
Zoom out?
Make it
Bigger.
larger. Yes,
Yes, yes, of course. Is that better? Yes?
thank you.
Of course. Okay, so it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Wait, I'm going to make it a little bit smaller. Plus 9. And then you just add all of those up. I guess like a faster way to do this particular one is you see that you have 1 plus 9, which is 10, and then 2 plus 8, which is 10. And you have that 4 times. 4 times 10 plus 5 is 45. So it's going to be the same for each of these. You just figure out what this equation is for each value of k, and you add them. Okay. So B is arithmetic mean and weighted mean. So arithmetic mean is just typical average. You add up all of these values and you divide them by how many there are. And then weighted mean is a little bit more complicated. You multiply the value by its weight, you add up all of those, and then you divide it by the sum of the weights. That is that. This is an optional problem. So that is the end of homework 4 problems. I guess if there are specific problems in homework 4 that people want to do, I mean, in homework 2.
Can you represent the you just did? So you said add value, right? Add all value. So value, and then you divide that by how many there is on the value.
Yeah, I can write it. Yeah. So sorry so for 1, you're adding all the values. So I'll just write this using the notation on the top. So you're adding all x and you're dividing by n, which is the number. So
x, okay.
That's for the first one. And then for weighted, you're adding all x times their weight. So it would be like 2 times 4 plus 10 times 6. Continue for all of them. And you're dividing it by the sum of the weights. So dividing it by 4 plus 6 plus 3. Does that make sense?
Yeah.
Okay, perfect.
Thank you.
Ava, there's a question. What do the k terms on the right of the sigma mean?
What do they mean? Well, this is just a notation. This is just making this long summation right here simpler. So k is just like, for the first round, k is 1. Second round, k is 2. Third round, k is 3. And it's just like, I guess, the variable that you generally use with like summation notation for representing what you're adding each time. So like for the second one, it would be 1 plus 4 plus 9 because you're doing the sums. I can write that in steps. So it's first, initially, k starts at 1. So it's 1 squared. Then k moves to 2. This is just how it works. It always just steps up 1. If it's more complicated than that, it'll say. So then it's 2 squared, etc., until you get to 5 squared. So k is just whatever that thing is, whatever your variable is. I hope that answers that question.
Yeah.
Go ahead.
Folks are confused. Santiago, can you clarify your question with problem 4? And yeah, we just went over summations again. Can you go over question 2 in part 3, Ava?
Question 2 in problem 3? This one? Or no? That's
right. Yeah, yep. In part 3, yes.
Okay. Yes, we can. So this is back to factoring. So if it's an x squared term, you know you're going to need to factor it into 2 x terms. So what you know here is that like you're trying to find these 2 values. So you know they have to multiply to 3 and they have to add to 4. So I think as you do more of these, you realize, you like start to just see it, but here it would be plus 3 and plus 1. So then always check yourself, see if you were to expand this, what would you get? So you would get x times x, x squared, plus x times 3, 3x, plus 1 times x, x, plus 1 times 3, 3. Which is equal to x squared plus 4x plus 3. So that's the same for all of these. Like this one, you know, difference of squares is just square root of the first one plus square root of the second one times square root of the first one minus square root of the second one. I hope that answers that. Are there any other specific ones in homework 2, or should we go to homework 1?
The last one example, can you simplify that with the square root?
The last one in what?
Can you simplify that with the square root?
I don't know which problem you're talking about.
The problem 3b4.
Okay. I mean, I can do that. I can do that too. This is the same process as I did for the one.
No. The number 4, IV. The last one you showed up was.
Oh no, that's the simplest. That's the simplest form that I would put that in.
Oh, you mean the simplest form? Okay.
Yes.
But
Yeah.
it can be solved with the square root, right?
Yeah, but this is asking you to factor it.
Uh-huh.
And this is what factoring this. This is the simplest factored form.
Isn't it 8 instead of 4?
Hey,
Yes.
whoever is writing on the screen, please stop or I'll have to remove you from the meeting.
Wait, whoever just corrected me, yes, you are so right. Thank you.
Can you please explain the problem number 3B first?
3B first one?
Yes, ma'am.
This one?
Yes. X
Okay.
squared plus 10x.
So in this one, you can see that you just look at what the biggest factor of x you can take out of both of them. So that's just x. So it would just be x times x plus 10. And that's just the simplest form that you can get for that polynomial.
Okay, thank you.
Of course. Are there any more here, or should we go back to homework 1?
Is everyone clear on problems 1 and 2 on homework assignment 2?
2.
Someone just asked, how are we supposed to write the polar coordinates?
I think in this one, it's just asking you, like you can do it in any way. You can just do r equals, like I did here, just r equals 5, theta equals, I didn't actually calculate this, but whatever it is, to the degrees, or like r theta. If you want to do it in coordinate form, it would be like that. But as long as you make it clear what's r and what's theta, I think it's fine.
And just a reminder for everyone, I'm sorry, I'm not a technical person, so I can't answer the question perfectly. You have unlimited submissions on Canvas, so like just play around with the decimals and like converting to radians. I'm trying to get an answer from the person who designed the homework assignment, and we'll try to let you know before this is over. But just as a reminder, you can submit unlimited time, so just in case you have to play around. Sorry, Ava, go ahead.
Yes. So will you guys go over the optional problems, or will there ever be will they ever appear on the homework to where we're able to turn them in there?
I'm not sure.
Yeah, again, the optional problems will not be submitted on Canvas, and if you have any questions about them, they should be asked on Piazza. We're going to focus on the required content here.
Can you please, anyone problem of the problem number 1, how to solve that problems without using the calculators?
Well, this one, I'm not sure which problem you're talking about, but this one you are allowed to use a calculator. Again, I'm not sure which one.
Before one. Problem number 1 without the calculators of the unit circle problem.
Oh, this problem.
Unit circle one.
Yeah, well, with this one, you can
explain.
They give you this unit circle with the coordinates of each of these, but also as you're doing these problems more, these are very typical angles, pi over 6, pi over 4, pi over 3, that you will see over and over again, and you will just start to remember the values that go along with them, the x and y coordinates that go along with them. But they do provide it all for you right here, so that's how you can do it without a calculator. Should we move to homework 1? What do we think? Does anyone have any more questions on homework 2? Any problems they want me to do? No?
Can you do 5? Homework 2.
5 is an optional problem, I think. We're not doing those right now. If you have questions about the optional problems, Piazza is the place to go.
Ava, on homework 1, someone had a question on number 2.
Okay.
I think D and E, trying to find the output.
Okay, we can do, should we start with D? We can do that. Okay. So let's do D. So first, you have your A, B. Like I try to build up to what the final expression says. So I know I need A, I know I need B, I know I need not B. And then finally, I have A exclusive or not B. This is how I do it. There are different ways to do it. You can do more of it in your head. I think it's just easier to not make a mistake if you have each step written out. So start from A and B, you just do all possible combinations. So if they're both 0, A is 0, B is 1, A is 1, B is 0, and they're both 1. So then simply, next column is not B. So you just take B and do not, which is just the opposite. So that's just going to be 1, 0, 1, 0. And then you're going to take your A column and your not B column, and you're going to do the XOR expression. So exclusive OR is only true if one of them is true. So if you look at these two columns, so these two, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1. So basically just try to do it one column at a time. And I mean, I guess if you don't remember like what OR does, you can always look that up. But yeah, I can do E also if that would be helpful. But it's sort of the same process, but I can do it. Okay. So again, you need your A, you need a B, you need A or B, you need a C. Okay, this is gonna get tight. A or B or C. Okay. So again, try to do it one column at a time so you're not making any mistakes. So these are always, you just put all the combinations. Okay. A or B, 0, 1, 1, 1. We need C. Oh, wait, this is going to be a very big truth table. I'm not going to go through all of this right now, actually, because C is going to be another 4 combinations. So that's going to create even more combinations. So I'm not going to have the space for that right now, but same process. Do one column at a time. Yeah.
Sorry, in this one, which one will be C? Which values?
C is a new value. C is a new input.
So I could put 0, 0, 1, 1, something like that.
Yeah. So in this, like the reason that I don't have the space for this is because there's going to be like 8 outputs actually, because you're adding a whole new input. Here, wait, let me. So, remember how I did the A and the B in the beginning and I put all the combinations of A and B? Since you're adding C, there are another 4 combinations. Because for each combination of A and B, C can be either 0 or 1.
Could you put there which value have C?
Yeah, here.
Please.
Yes. I will do it.
Thank you.
Of course. Okay, here, I'm just gonna write this again and we will go all the way through it.
Because the last column I can resolve it. I could do that, but the C is what I don't understand. What can I put there?
Okay, wait, why is this stopped again? No. Okay, we good? Okay. So the reason that this one is different than the other ones is that now you have 3 inputs. So you're gonna have more possible answers. So we're gonna start with A, B, and C. So first combination is they can all be 0. Then A and B can be 0 and C can be 1. Then you have B can be the one with 1, and then A can be the one with 1. And then you have the options when 2 of them are 1. So A is 0, B and C are 1. A is 1, B is 0. Oh, wait. I want to do this in a better order. You can have A is 1, B is 0. You can have 1, 1, 0. Did I do that correctly? I think so. And then you have 1, 1, 1. So that should be 8 combinations of those 3. And you can like find that out because like 2 to the 3 is 8. So there should be, if you have 3 inputs, there should be 8 combinations of those 3 values of 0 and 1. Okay, so then you continue with your truth table as you were doing before. So next value that I would do is we need A or B. So I'm going to do that. I'm going to do A or B. So that's going to be 0, 0, 1, 1, 1, 1, 1, 1. Then we need A or B, exclusive or C. So then again, you're looking at, you're looking at these 2 columns and you're doing the exclusive or operator. So it should be 0, 1, 1, 1, 0, 0, 1, 0. Because exclusive or is only 1 if you have a 0 and a 1. So that, I hope, answers that question. I hope that's right. I hope I did in the right order. Yeah, that should be right. So yeah, I guess it does get a little bit more complicated when you have more inputs just because you have more rows, more possibilities, but as long as you try to keep it to only doing 2 columns and 1 operation at a time, then you're probably not gonna make a mistake. Okay.
Could you please draw the logic circuit for problem 2E?
Yes, I can do that. I'm gonna need a little more room. I guess I can just erase this. So all of these are built with the same, the same few gates. So here you have 3 inputs, so you're gonna have a little bit of a bigger diagram, but just start with the simple ones, so A and B, and you wanna do your OR gate. So that'll just be like, not the most fabulous artist. Okay. Okay, so that's A or B. And then you also have C, which is separate because it's this XOR C. So C is gonna go with A or B and it's gonna go into a big XOR gate, right, like that. And then your output's gonna be something like D. I hope that's.
Yeah, thank you.
Of course.
Ava, someone's asking if you can have one more example in problem 1.
In problem 1.
Yeah, the trigonomic functions.
Oh, and homework 2, problem 1?
Oh, sorry, maybe? Yes, yes.
Yes, okay.
And then someone else was asking about homework 1, question 1, so maybe we can do that next.
We do that after, okay.
We'll try not to make people too dizzy.
I know. Okay, let's do, should we do one of the tangent ones? Because those are a little bit more complicated. I think, yes. Okay, let's do this one. So tangent of 2 pi over 3. So first thing I would do is find where your, okay, I'll just write it up here so we can look at this really big. Okay, so we're trying to find tangent of 2 pi over 3. So find your 2 pi over 3, which is right here. Okay, let me not ruin the diagram. Okay, so tangent, you know, is opposite over adjacent. So if you draw your triangle like this, this is your opposite side. No, not an X. That's your opposite side, and that's your adjacent side. So opposite is going to be the y coordinate, which is root 3 over 2. This is root 3 over 2, this right here, because you know that that's the y coordinate of this point. And then your adjacent side, which is this, is the x coordinate of this point, which you have right here. It's minus 2. So tangent is opposite over adjacent, so it's opposite over adjacent, which is simplifies to minus root 3. Yeah. So it's the same for each of these. You just find your angle, find which one, like go to the point, and then they give you the x and y coordinates right here. So you know, like for this triangle, for example, this pi over 4 triangle, you know that the x coordinate is this, root 2 over 2, and the y coordinate is this, root 2 over 2. And then whatever it's asking you, if it's sine, you know it's opposite over 1, so root 2 over 2 over 1.
Ava, Steve is reminding us of SOHCAHTOA. Can you write that out just for people who might not have heard of it before?
Okay, yeah, I didn't want to do it in case it would confuse people, but yes, I will do it. Okay, so this helps you remember like which sides. So it's SOHCAHTOA. So the S is sine, the C is cos, and the T is tangent. And SOHCAHTOA means this is the opposite side. Sine is the opposite over hypotenuse, cos is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So when I was saying like tangent is opposite over adjacent, like that's this. That's from here. But yeah, that is important. That's, yeah.
Perfect.
Okay.
I wanna pause just really quickly. This is our first time doing this. We have 10 minutes left. I'm gonna do a really quick poll just to figure out how useful this has been for people, just so we have some feedback. And then in the last 10 minutes, Ava can answer any final questions. Awesome. Okay, I'm glad it's been super useful for most people. If you have like thoughts or feedback, feel free. Someone said very, very useful. That's great. Feel free to find me on Discord. I'm Rachel, who posts all the time. Let me know what would be helpful for future weeks, but also just remember, like, this is not for the optional problems. It's intended to be like very much so review for those who are struggling. So if you have feedback along those lines, feel free to send it to me. Ava, maybe slow down a bit. I guess we're hearing.
Okay, sorry.
That's okay. Ava's also like been amazing and just hopped in to help on this. So we're really grateful for her. We do still have 10 minutes left, so sorry for interrupting. If there are questions, like final call for questions on homework 1, and then we'll do a final call for questions on homework 2, and then we'll wrap up.
Hello.
Yeah, go ahead.
So can you solve that from polar to coordinate to polar conversion from problem, homework 2.
Okay. Should we do last call on homework 1 first, or should we just move to that?
Yeah, any final questions on homework 1?
Could you like explain the conversion of A on problem 1 homework 1?
A, problem 1, homework 1. Yes. Do you have a specific one? I'll just choose one. Okay, so if we're doing 2, it's not showing up again. Okay, I'll write and hopefully it'll show up. No, not working. Okay, until it decides it wants to start working again. So generally how I do these is if you're going from binary to base 10, I like to write it out with the place values. So I would write, like, say we're doing A2, 1, 0, 1 in binary. So I would write 1, 0, 1, and under each of them, like under the rightmost one, you know that's the 2 to the 0th place. And then you know, I really wish this would let me write. You know that the next one is 2 to the 1, and the leftmost one is 2 to the 2. So then you would have 1, 2 to the 2, 0, 2 to the 1s, and 1, 2 to the 0. So you just add those up. So 1, 2 to the 2 is 4, because 2 squared is 4, and you have one of them. You have 0, 2 to the 1s, so you don't have to worry about that. And then you have 1, 2 to the 0. 2 to the 0 is 1. So it's 4 plus 1, which is 5. This might be hard to imagine in your head, but I really don't know why it's decided to do this again. Should I stop my share again and start again, or? Oh, yeah. But it's doing that, but it doesn't see. Okay, yeah, who knows? So this is what I was saying. So you write it out and you write the place values underneath. So this is the 2 to the 0th place, this is the 2 to the 1 place, this is the 2 to the 2 place. And if there's more, you just keep writing them. So you know you have 1 times 2 to the 2 plus 0 times 2 to the 1 plus 1 times 2 to the 0, which is 4 plus 0 plus 1, which is 5. So that's how I would do conversion of, there's many ways to do this. You might have seen a different one in lecture, but this is a pretty simple one.
Can you do it with only like the bigger numbers?
Yeah,
so, like,
of course. Yes, I can do that. Okay, I'll do this one. So write it out the same way. We have 1, 0, 0, 1, 1, 0. So did I do that right? Yes. Okay, so 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Okay, so that's going to be 1, 2 to the 5, which is just 32, plus these two are both zeros, you don't worry about them, plus 1, 2 to the 2, which is 4, plus 1, 2 to the 1, which is 2, plus another 0. So that is just 40. No, 38, sorry, 38. Yeah. Does that make sense?
Yeah, so you start from the most right one, and then you start off from like 2 to 0 and keep on going up. If you
Exactly. Here, I can show you like the reason. It might look weird seeing it the first time in binary, but if you look at, for example, the number like 217 in decimal, just like normal 217, you can do the same thing. So this is the 10 to the 0th place, or we would call it like the digit place, not the digit. What do we call it? The ones place, because 10 to the 0 is 1. This is the 10 to the 1 place, or we call it like the tens place. And this is the 10 to the 2, or the hundreds place. So it's just place values, but in binary. Hope that makes sense.
All right. If whoever was asking a question about homework 2 wants to ask that again, you can.
Yeah, I was asking about, can you do the polar to coordinate conversion and vice versa problem?
So we did a few of, oh no. Okay, so we did a few of those before. Maybe you weren't here. Is there a specific one that you want me to do, or I can just explain the process. So the important things to remember when doing these are just these two formulas. So x equals r cos theta and y equals r sine theta. And so, like, for example, in this one that we did before, you can just draw it out in Cartesian coordinates. So it's 3 along the x, 4 along the y, and then you can use Pythagorean theorem, since these are always right triangles, to do 3 squared plus 4 squared. It's 25, square root of 25 is 5. So you know that r is 5. So that's how you can find r. And then you can plug r equals 5 and x equals 3, for example, into this equation here to find what theta would be.
So all we gotta find out is the angle, right?
You need, so polar coordinates are r, which is the distance from the origin, and theta, which is the angle from the positive x-axis. So like this point in polar, you need theta and you need r to define that point. So those are the two things you need to find.
And what we have to do in question B, convert the following from polar coordinates to Cartesian. How we got to do that?
It's the same thing. You use, I mean, it's the opposite direction of the same thing. So you use these same two formulas, except now you have r and theta instead. So like for, I guess,
and
like
we got to find out x
and y.
Right?
Yeah,
Okay,
exactly.
I got it.
So like I generally draw it out, you know, this, say it's this one. This is pi over 4. This is 3. And then you can just use these two formulas. You want to find what this is and what this is.
Okay. Got it.
Okay.
Okay, thank you.
Of course. Is there, I guess we have 2 minutes. Quick questions on either homework, clarifying things?
The conversion of like numbers to like regular numbers to binary, homework 1.
Yeah.
Like.
Oh, you want to do the other way? Yeah, of course.
Yes.
Sorry, yes, of course, we can do that. Okay, I'll start with the bigger one. So say we're doing this one. Say we're doing 50. So again, there are many ways to do these conversions. This is just the way that I do it. So I start with my number, and I just keep dividing by 2, because the way that binary is represented is by powers of 2. So you're trying to find the powers of 2 that fit into 50. So how I do it is 50 divided by 2 is 25. And then I always write the remainder. So remainder 0. Whoops. Okay, so then 25 divided by 2 is 12, remainder 1. 12 divided by 2, whoa, that's not a 2. Divided by 2 is 6, remainder 0. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. And then you're done, because you got to 0. So then how you find the binary number if you do this is you just read up this way, these numbers, these digits. So it's just 1, 1, 0, 0, 1, 0. That was definitely a little bit fast. I'm sorry, but this is the same process that you can do for all of these. Just keep dividing by 2, write the result and write the remainder. And then as soon as you get to 0, you know that you're done, and you can just read from the bottom to the top of your remainders. And that will give you the binary number. Of course.
Great. We'll take one last question and then we're at time.
Yeah, I have a quick question. Also regarding pronunciation. I mean, cosinus reversed is the same thing as arc cosinus, right?
Yes.
All right, that's it.
Okay.
I just wanted to say thanks so much for hosting this panel session. I know it definitely helps out a lot of individuals, and it was definitely good for me to get a little review session. So I just wanted to say thank you.
Thank you.
Okay.
Yeah, thanks a lot. It is a great help because I had some doubt regarding that. So it was
I'm
a great.
glad it helped.
You please clarify one quick question, please.
Yeah, go for it.
Is pi over 4 the same as 9 pi over 4? Is there something to do with the direction in the unit circle? Like counterclockwise and clockwise?
That's a good question. So, whoa, that's an eraser. Okay, so super quickly. So pi over 4 would be here. And this is the positive x, y, pi over 4. So 9 pi over 4 is the exact same as pi over 4 because 9 pi over 4 minus 8 pi over 4 is pi over 4. And 8 pi over 4 is the same as 2 pi. So that's just a full rotation. So it doesn't matter that you did that full rotation because you're in the exact same place.
Okay, thank you.
Does that make sense? So yes, you're right. Is that the same?
All right. Any final thoughts, Ava?
No, I hope that helped.
Well, I just shared in the chat. We'll do another session for homework 3 like this next week. Hopefully it'll be even a little bit easier to follow because we won't have 2 assignments to cover. Final reminder, please get on Canvas. We will not do last minute troubleshooting. It's just way too much work for our team. So please get on now. And again, we want this class to be empowering for everyone. So you can submit your assignments as many times as you need to, keep practicing, and we'll try to make the Canvas submissions even a little bit easier next week. So decimals, radians, all that isn't quite as confusing for students. So thanks for your feedback and have a wonderful evening or morning wherever you are in the world. Bye. Happy Halloween.
Yeah, all right, bye.
Thank you.
Happy Halloween to you. Thank you.
Thank you. Bye-bye.